Okay. So I know last year Mr. Meat talked with you about unit rate, right? That was a big thing we did last year in 7th grade was unit rate. And he would give you problems like this. Hey, here's a box of pencils. There's 12 pencils in this box. This whole box you can buy for $2.49. But what if I only want one? I want one pencil. How much would one pencil cost? And you guys did what? You divided. You divided $2.49 by 12 and you figured out your cost per pencil. And he called that unit rate. Or even before that, Miss McClendon or Mr. Seville called it unit rate. That was a 6th grade thing, right? So when you got to 7th grade, Mr. Meek said to you, hey, remember how you learned unit rate last year? Well, this year we're going to call it constant of proportionality. Do you remember that phrase? Yeah. And constant of proportionality is the 7th grade word for unit rate, right? So it started out as unit rate, and then it got turned into constant of proportionality. And in 8th grade, it still means the same thing, except we're not calling it one of these. We're calling it rate of change. So did you get that much from yesterday? So rate of change. And so how I'm going to help you kind of learn about rate of change is I'm going to give you a little scenario about my daughter who works as a nanny down in Oklahoma. She goes to Oklahoma State University, and she doesn't deliver pizzas or go to the work at the convenience store or the bookstore like college kids do. She's a nanny. She drives. She picks up kids in the morning. She takes them to school. She goes to class. After class, she picks them up from school and takes them to karate. And then she goes back to another class. And then after karate, she picks them up. And then at the end of every week, she turns in how many hours she was on the road or babysitting or doing whatever, and then she gets paid, okay? So having that in mind, let's talk about this. Let's say that she gets paid $8 an hour, okay? And you're going to be, I know, I feel like it should be a little bit higher, right? So X and Y, you're going to see two kinds of tables, right? Either a vertical T-chart table or a horizontal one. So everybody, eyes up here. Everybody? Yes, you there, ready? Okay, so you can tuck that in the window if you need to. So the first thing I want you to understand is X and Y in Unit 3, and for a minute, we're going to forget about function notation. We're going to forget about f of x for right now, okay? X and Y are now taking on meaning. X is no longer just X and Y is no longer Y. They mean things. And normally when you're dealing with cost, Y is going to be your cost. We'll go later into independent and dependent variable, what depends on what. So doesn't the amount of money she makes depend on the number of hours that she works? She gets paid based on how many hours. So Y is almost always your cost because it's your cost that is doing the depending. It depends on how many hours. It depends on how many jobs you did, how many things you sold.
Because Y depends on X?
Yes, Y depends on X, and X is their independent. Very good. So that means X is usually going to be your unit of time, right? Because time is independent. So this is going to be the number of hours. X can also be your number of items. How many pencils, how many anything, okay? So usually in the world of work, if you don't put in any hours, you don't earn any money, right? That's usually how it goes. So on Monday morning, before she even picks the boys up, she has not earned 1 hour, which means she's earned $1. Okay? But the first hour that she clocks with those boys driving them around Oklahoma, she earns her first $8. And then her second hour on the job, she's up to $16. Like, this chart makes sense to you, right? It's pretty easy. It's pretty straightforward. Okay, if you're looking at it vertically or horizontally, 0, 0. 1 hour is $8 an hour. 2 hours is 16, and we could keep going on forever, right? But I want to take a closer look at this chart. I don't know if you noticed yesterday in the notes what I did is I kind of did these things. And I know Mr. Meeks taught you, and he taught you constant of proportionality, he told you this. He did triangle Y over triangle X, and he said delta Y over delta X. Does that ring a bell? Yes. And delta is like a fancy way of saying the change in. What are my X values changing by? They're going up by ones. So I'm going to put a +1 here and a +1 there. What are my Y values changing by? 8. So I'm going to put a +8 here and a +8 there. Okay, so remember how I always start you off with the most basic problem? This is as basic as it gets. It goes up by ones. My 0, 0 is my starting value. You don't work, you don't get paid. Going up by ones. If that's the case, then this number is your rate of change. It's your unit rate, right? Because for 1, it's 8. So my rate of change equals 8. All right? And that's all I need you to do for part 1 right now. All right? And here's a little bit weirder when they're kind of horizontal like this. This is going up by 1s. It's the same chart, just written differently. You're going to see them more horizontally than this. And here's what's a little tricky. You have to be able to look at it and say, it's not the x divided by the y. It's always the y divided by the x. But here's the deal. You don't even need to divide when that's going by 1s. Yes?
So for example, could we write f of x equals 8x?
Yes.
And also, I've noticed that, like, the whole thing, like, if 0 is a number you, like, for example, say it's 0, -3, you'd write 8x minus 3.
Yes.
What if it's 0, 0? Do you just not write it?
Yes, very good. You are about 5 minutes ahead of me, but yes, when it's 0, 0, because basically what he's saying is, Mrs. E, I know what you're going to ask us to do. Once you find the rate of change, you want us to put it in an equation, don't you? Yeah. Okay, and he said, well, y equals 8x, because the cost is $8 an hour. And because she didn't get anything to start, then there's nothing after that, and they're absolutely right. So we'll get there for those of you who didn't follow that. Okay, what if one day I say, hey, 0, 0, 2, 16, 4, 32, and 6, 48. So let's say this is our table. First thing you're going to do is find the change in each of the values. The change in the x is going up by 2. The change in the y is going up by 16. 16 plus 16 is 32, plus another 16 is 48. Okay? So, the biggest mistake kids will make, because I always like to give you that, hey, heads up, is they do these things, but then whatever number's in the bottom, they say the rate of change is 16. She's making $16 an hour, because there's a 16 there. No, she's making $16 for every 2 hours. So if she's making 16 for every 2, she's really making 8 for 1. So that's why it's this number divided by, because that's the change in the y, divided by the change in the x. 16 divided by 2. So this is the same data, just written differently, okay? So I'm showing you this because it's not always going to go by 1s. There are going to be times where it doesn't even go by a consistent number, and let's talk about that next, okay? Let's get to what Ashton said. He said, so in other words, the cost is equal to, well, actually I don't want to write that word yet, is equal to, I want you to write this sentence. Oh my gosh, start over. The cost is equal to the hourly rate times the number of hours she works. So let's say this lady, she has 2 little boys and she has a new baby girl. That's why Emma's doing all this driving, because she does not want to get out with the new baby girl. So she says, oh, every Friday when Emma gives me her hours, I'm just so confused on how to figure out what I owe her. I want to put a Post-it note on my refrigerator with a formula, with an equation that I can just plug one little hour into and poop, there pops out her hours. So that's what this sentence comes from. You have to agree with that. Do you agree that the cost to her, to the lady that she is going to pay her, is equal to whatever she chose for her hourly rate times her hours? Okay, so let's translate. You guys have Language Lab. You translate languages all the time. We're going to translate English into math, because math is a language. It just uses numbers and symbols instead of words, right? So the cost, oh, this was helpful. I got to go back up to my chart, and I got to remember if that's X or Y. And usually, what do we write first? Y. This is where I said, go ahead and forget about that f of x business for now. It's easier with the y. Oh, so the cost is y. Okay, y is equal to, what do those 3 words tell me to write? Equal sign. Hourly rate. Oh, hold on. Let me go back up in my chart and see what the hourly rate is. What is she getting paid for per hour? It's the rate of change. And the hourly rate is what? I have to figure that out. 8 times the number of hours that she works. Do I have a definitive answer on every single week it's going to be the same number of hours? No, it might change. So what could I put in place of the number of hours worked if it's going to vary? Why do they call it a? X. Yeah, they call it a variable because it varies. So X is the number of hours. So look, this is where Ashton said f of x equals 8x. Let's, for right now, forget about that function notation. Do you understand where y equals 8x comes from? Here's another reason why. Hey, do you agree that all these y values came from this x value times 8? 1 times 8, 2 times 8, 6 times 8, 4 times 8. I mean, that's what y equals 8x means. So now finally, this lady has a Post-it note on her refrigerator with the formula y equals 8x. And on Friday, Emma says, here you go. I worked 12 hours this week. All this lady has to do is go, okay, so my cost to you will be 8 times the 12. I know it seems really simple, right? Yeah, you're going to owe me $96. Thank you. See you next week. Okay? So are you okay with rate of change? Rate of change just is how much per hour. Okay, sometimes they will try to trick you with rate of change. They might say, okay, here is a 1 and a 3 and a 7 and a 10 and a 40 and a 100. And you might look at that, and I will tell you, every time you have a table, the first thing you're going to do is figure out what's the x's going by and what are the y's going by. I'll give you a minute to copy that table. For every, this is going up by 2, but this one's going up by 4. That's not good. If this is going up by 30, 40 to 100 is going up by 60. If this happens to you, and it's not a nice, neat 1, 2, 3, 4, 5, okay? And this is even worse than 2, 4, 6, 8. At least these are going by the same number, right? So you know to just divide. It doesn't change things. You still divide the change in y by the change in x. But if you are a highlighter person, this is where a highlighter would come in. You're going to divide this change in y by this change in x, which is 30 divided by 2, which is what? 15. Then you're going to divide this change in y by this change in x. They're partners. And what is 60 divided by 4? It's also 15. Oh, so if I do that 10 times and I get 15 every time, then 15 is my rate of change. If you do this 10 times and when one time it's something different, it means one of two things. Either you calculated wrong or I made the problem wrong, because they should all be the same, okay? So my rate of change is 15, yes?
So really we only need to do 1?
I would always do 2. I love what he's thinking. Technically, yeah, I would, but I've had kids calculate 1, and for some reason they do a little calculation error. If you do 2 and they're both the same, you can be pretty sure that it's right. Yeah, you would only need to do a couple. Very good thinking. I know that you understand it now because of that question. Okay, so does that make sense? All right, be careful because sometimes rate of change doesn't always go up. For example, this is not a
Teacher, sorry for this
money problem.
Janelle Roberts to the office, please. Janelle Roberts to the office.
Okay, I want to put that right there for a minute and have you see if you can come up with a real life scenario that would be. For every something else goes down by 4. Because 4 to 8, yeah, Haley. Yeah. So the cost out in your pocket, like say you start with a certain amount of money and then it went down by 4. So every time you buy something, yeah. Awesome. Perfect. That's exactly the example I was going to use. Every hour past midnight, because the sun goes down, it gets colder, the temperature drops by 4 degrees. It doesn't mean that it is 4 degrees. It just means whatever the temperature was at midnight, 30 degrees, now it's 26, now it's 22. Very good. So be careful, and that's why I put pluses here. Because sometimes it's going to go down. So be careful. So my rate of change here is -4. And you can come up with whatever scenario you want. Okay, that's part 1. Rate of change. Are you okay with that? All right, so I want you to try this one real quick. And you can kind of use Colin's advice here. But, I want you to see what you get here. All right, that looks like a big old mess, doesn't it? X, Y. Just literally start by doing what's in red. That will save you every time. Because patterns in math tell us things. I know it looks like a pattern, but it's not the same number each time. And technically, should it work for all of them? Give you guys a minute. Okay. All right. Yeah. Yeah, -3. Yep, exactly. Okay, I do want to show you one thing that this seems to be the craziest thing. What if I reversed these? What if instead of 1, 3, 6, 8, and 11 on the bottom, I put it here? 1, 3, 6, 8, and 11 on the bottom. And then the 8 and the 2 and the -7 and the -13 and -22 on the top. Watch. This is going up 2. This is going up 3. Up 2. Up 3. Hey, this is going down 6. This is going down 9. Down 6. Down 9. Okay? I know, man, I don't know why, but every year kids have like whole numbers are the best. I love whole numbers. And if I get a fraction answer, I must have done something wrong. Nope, not in algebra. So I know you look at -6 and -2 and your mind instinctively wants to say -3. But what is the change in the y? 2. What is the change in x? -6. Don't tell me that's -3. It's not. It's what? -1/3. Can you have a fraction slope? Sure. 33 cents. You lose 33 cents every time you leave the lights on in your home and you don't turn them off and save electricity. Yeah.
Could you repeat number 4 in the worksheet we got yesterday? Because I want to know how to do a problem like that.
Yep. I'll get there probably right now. Okay. So are we good on rate of change? All right, because now we're going to go back to Emma because it's getting close to Christmas, and Emma's been working for them for a long time, and she's working hard, and they sat down, and they said, we want to give you a bonus because you're such a hard worker. So starting next week, we're going to give you $50 just because. You got Christmas coming, you're a college student. Here's an extra $50, and you're still going to get paid your $8 an hour, but here's $50. How does that change things? How does that change what my table looks like? If y is money and x is the number of hours, this time when I put that she hasn't even worked 0, it's going to be 50. Awesome. Good job, Em. Right? You worked hard. You got $50 and you didn't even work an hour yet. What does that mean then when I put a 1 here? What's her total earnings? 58. So I guess you can probably figure out how much she will have earned after working 2 hours. 66. Okay. This is officially where part 2 of the notes start. Part 1 of the notes is video 1 that said, hey, what's the rate of change? All you need to tell me is, 8 is the answer. 15, -3, part 2. Here we go. So let's go back to that Post-it note that's on that lady's refrigerator. That's helping her learn how to calculate what she has to pay Emma. Right now it says y equals 8x. And in there she puts the number of hours Emma works. How does she need to alter this equation for this week, Haley? Yes, she has to put a plus 50 here. Because look, I don't know if I used my highlighters as much as I should have, but I did it on the first one. 0, 0, 0, 0, 0, 0. Oh, hey, these ones didn't have zeros in it. But it's not 0, 0 anymore. And this is what Ashton was kind of getting to with his original question. Oh, it's 0.50? So if I don't work any hours but still get paid, that must be like a bonus or a starting fee. So this little plus 50 means you didn't, because here's my question. How many times does she get paid that $50 for this week? Just once. How many times does she get paid the 8? It varies, right, on the number of hours she worked. So what your job is going to be to do is to say, okay, Mrs. Z always says it's going to be the cost, the y is going to always be there, the x is going to always be there, and my job is to just do what? I just have to figure out what number goes here and what number goes there. Yep, that's all you got to do. Don't reverse them. Emma probably wishes that she reversed it. Right? Why? Yeah, if Emma said, oh, you got, my mom's an algebra teacher, let me help you with this. You should put the 50 here and the 8 there. Yeah, I'll start with an $8 bonus if you pay me $50 an hour, right? So do you see what each spot means? They mean two totally different things, okay? So I want you to write this equation, and I want you to point to these two spots. And the number in this spot we call our initial value, our beginning value. So go ahead and put beginning, because that B is going to come back into play in a minute. Beginning value, and I want you to underline the word B, or the letter B. And this is, as you know, my rate of change. Okay. And you just have to know where to put it. So if I were to say to you that Blockbuster, you guys probably don't even know what Blockbuster is. It's like a video chain that, like, we used to go rent VHS cassettes from every Friday night. Now you could just, like, say, speak it in your living room and somebody will play it on your TV, like, real creepy. But there used to be, so let's say Blockbuster's going out of business, and they want to get rid of all their Blu-rays. So if you join for $20, one-time $20 fee, you can buy as many Blu-rays as you want for $4. Not bad. But you have to pay the $20 to get the $4 price. If you don't want to pay that $20, you have to pay $10 for every Blu-ray. No. So this is per Blu-ray. So let's write two different equations. This one's the easiest one. $10 per Blu-ray means what? Just like y equals 8x for $8 an hour, then what? Y equals 10x. Your cost will equal $10 for every Blu-ray you buy, if that's the option you choose to go. Or $4 a Blu-ray sounds pretty enticing, right? But you got to pay $20 to get it. So it kind of depends on how many Blu-rays you want. If you walk into that store and you only want one, which option are you going to choose? Yeah. If you want two, which option are you going to choose? $10. If you want 5, I'm going to say, here's $20. Give me my 5 at this rate. Do you see the difference? So we wrote this equation. Let's write this equation now. Go, write it. Try to see if you can come up with it. If I told you that you're always going to have... So you have to ask yourself, what are you paying one time and what are you paying multiple times? So, Hallie, go ahead. Yep. Okay. Are you good with this so far? Yeah.
Wait, I always thought, wouldn't it be subtraction since you're, like, giving them $20?
No, because it's the cost to you. Y is equal to your cost. Okay, so now let's do a little bit trickier. So is this helping a little bit to clarify? All right, there's two different parts to it. So if I say 2, 4, 6, 10, did I do this one yet? 10, 30... 50? All right. This is Emma's hourly rate. We got to figure a couple things out. So I'm looking for my rate of change, and I'm looking for my starting value. Beginning value. Well, my instinct is always just take care of that rate of change. It's going up by 2. Awesome. It's going up by what? Yeah. Oh, I was thinking. Yep. 20. Thank you. Looks like she got a little raise, huh? Yeah. Because, how do I know right away she got a little bit of a raise? Because what's this hourly rate? Is she making $20 an hour? No. A lot of people will not pay attention to that detail, and they'll say $20 an hour because that's the number that's there. Oh, it's the Y. She's making $20 for every 2 hours. So how much is she making now? $10. Did she get a bonus this week?
Yes.
Not only did she not get a bonus, oh, actually, no, there's no bonus at all, right? I'm going to show you another. How do you know? Okay, 2 ways. The first way is to say, well, I know that starting value is when X is 0. But man, there's no 0 in that table. So I guess here's when you have to play hide and seek. It's there. You just have to go look for it. What do you mean look for it? Well, if this is going up by 2s to the right, can I just go back 2 to get to 0. So let's go back to, I'm 0. And if I went back to here, then I better do what here? Back 20. But what does that mean? It's at negative 10. Oh, yeah. Emma broke a vase while she was playing basketball. I'm just making this up. With the boys in the house. So what is her one-time fee? Minus 10. So the Post-it note on the fridge this week is going to say y equals 10x minus 10. I'm going to pay you $10 an hour, but you're going to pay to replace that vase. Does this make sense to you? If y represents Emma's money that she gets to put in her pocket, and if she works 12 hours that week, I earn $10 an hour, which means I made $120. Oh, but I got to pay for that vase, so I only get to take home $111. So do you understand the purpose of this number and what it stands for? Okay? If y is total cost, total thing I'm getting. So that was one option. But here's the deal. I'm going to be totally honest with you. Sometimes this option is messy. It is not good. And Peter actually said, my sister showed me a different way, and I thought that's so awesome because I was going to show you guys that exact same way today. Because I'm going to show you a couple problems. Like, watch. Here, let's do this. 10, 12, 14, 16, 6, 12, 18, 24. Let's just go with what I just showed you. Let's find my rate of change for every 2 that this is going up. This is going what? Oh, this is not a good one to do it for, but yeah, hold on. I'll show you. This is going up 6. So, no, this works. So what's my rate of change? The y divided by the x. So my rate of change, is, not y equals, 6 divided by 2 is 3. So you know what that means? That means right now I know one of the 2 things I need. I know that y is equal to 3x, right? What do they want me to do? Am I going to keep going back by 2 every time until I get to 0? That's a pain in the butt. And I will promise you a faster way if you want to watch. Go back 2 and get to 8. Go back 6. Go back 2 to get to 6. Go back 6. Pain in the butt. This way works every time, guaranteed. And if you are an equation-solving rock star, it'll be even better. So do you agree so far of the 2 things I need to know, I only know one of them? Do you agree then that what I'm trying to find is the beginning value? So I put what I know, and then I put a B in for what I don't know, but want to know. And then I use simple substitutions. Simple substitutions meaning I have a y and an x and a b. There's 3 unknowns there. If you input 2 of them, could you solve for the third? You sure can. Where can I get my hands on an x and a y though? I don't know. Maybe in the table right there? So could I use x for 10 and y is 6? Sure. You don't want to use that ordered pair? Use whichever one you want. Could you use 12 for x and this 12 for y? Could you use 14 for x and 18 for y? You know what I do? The smallest. Just use the smallest. So if x is 10 and y is 6, watch what's going to happen. You're going to love it. It takes all the guesswork out. So put 6 here. Put 10 here. Plus b. Do a little bit of math. Cancel out a constant. And you'll have b. So 6 is equal to 30 plus b. Subtract 30. Subtract 30. Negative 24 is the b value. So I'm not done yet. I got to go back and put it up there. Oh, okay. So you mean it's $3 an hour minus 24? Yup. You would have been there a really long time. You would have been going back a lot of times until you get to that. So let me just show you this exact same thing with the problem we just did previously, and then we're done. I promise. I know it's a lot. So let me go back up to this problem. And let's pretend like I didn't know that it was negative 10. Right, real easy. But by the way, was that a kind of an easy one? Could you decide which option you want to choose depending on the problem? Yeah. Let's just do it for this. Let's say y equals 10x plus, I don't know what that is. I don't even want to think about it. It might be easy, but I like algebra. So I'm going to pick one of these ordered pairs. Hey, let's pick x at 2 and y at 10. So 10 goes here, and 2 goes here, plus b, right? Do you see where the negative 10 is going to come from? Plus b. And then you subtract 20. There's your negative 10. Oh, so negative 10 is b because I just plugged it in? Yep. This is a surefire way every single time to get the right b value. Unless it's like, oh, I'm just going to go backwards 1. Okay? So I'm going to give you one more to practice. I'm not sure which one this works out to be, but let's see. Ready? Negative 2, 4, 6, and 8. And 1, negative 2, negative 3, negative 4. Go. Write it down. Use your pencil and put marks here. Don't do it in the air with your finger. Do it on paper. At least this isn't a bad fraction to have to work with, right? I'm going to give you a minute to find your y-intercept. Remember, whatever value you put in for x, you're going to have to take a half of it. Choose an even number. Luckily, they're all even numbers. You can deal with negatives or not. I'll just use this first value. And you guys just use that first point? So be careful. You want to know another big mistake? They'll put this first one in here and the bottom one in here. That's the x. That goes here. This is the y. It goes here. So make sure you have 1 is equal to negative 1/2 times negative 2 plus b. So what's half of negative 2? Negative times negative is positive, and then that is positive 1 plus b. Subtract 1. This works out cool because 0 is equal to b, which means what? Yeah, it starts at the origin. Because if it goes up a half, if it goes up a half here to get here, then it's going to go up 1 here to get to that. Okay? All right. Does this help a little bit? Okay, good.